Hi, welcome back to the Statistics lecturing series. We are in this unit, random variable and the distributions. This is the video number 2 for this topic. And for the previous video, we talked about how do I find the marginal distributions and conditional, the marginal distribution for both random variables, for both continuous and the discrete random variables. Okay, so today in this video, we're going to focus on how to find the conditional distributions for both discrete and the continuous random variable, and how to check the independence of these random variables here. Okay, so they are very similar. Okay, so now let's go to the here. Okay, so what is the conditional probability distributions here? So in here, I'm just going to, do a very brief reviews here. And then you will see what is this definitions is about. When in the probability units, we say the probability of the A given B's, right? So that means we want to find the probability of the A given that the B already happened. So if you remember, what is this very important conditional probability? We say this is the PBs, right? And what is the top here is the probability that A intersect B, correct? If you remember, that's what we say, hey, the reason why is because you have I think maybe okay. So the reason why we say is because you have like A and the B's, right? So now we say A and the B's here, when the B is happen first, that means it's in this circle, and then the A happened. So that means under the B happened, the A happened is this intersect circle, right? So that's why we say the conditional probability of A given B is equal to the PB, and then the top is A intersect B. So the conditional distribution is exactly the same, right? So now they want to find let's take a look here. So if they say, if I want to find the probability function of X given that, right? So given that the Y is already happened. So what happens here? So that's why the H of the Y. So instead of, so that's why I'm using the marginal distribution of the Y. Then what is the top A and the B's, right? So that means it's a joint distribution. So the same things here, if you want to find the conditional distribution for the, if you want to find the conditional distribution for the, the Y's here, right, given X. So that's what happens here. What do you do here? You put the GX on the bottom is your conditions, right? Then the top is A intersect B. So that will give you the F of X joint distributions here. Correct? Okay, so now, we're going to talk about the joint probability distributions here. Okay, so now let's take a look here. So this is the PDF for the 3 variable X, Y, Z, and I think we did, we did some, do the marginal at the previous video, but we're going to use that results here. So I want to find the conditional distribution of the Z given that X equal to 1 and Y equal to 2 here. Okay, so now let's take a look. How do I do it? All right. So the first thing is here. So let's try to write it. What do we try to find? So this one's here, they say, I'm trying to find the probability distribution given that of the Z, given that X is equal to 1 and Y equal to 2 here. So based on my definition, so what is my denominators here? My denominators here has to be what? Whatever is your condition, right? So right now the condition is x and y, so I need to have the marginal of x and y. Now, what is the top here? The top is the PDFs, right? So this will be f of what? X and y's here, right? So what is x here? X is 1, y equal to 2, and z's here, right? Okay, so now let's go back to what we just did on the previous one. So let's see, we still remember what is our marginal x and y. So here we did here, right? Good, x and y's here. What is here? xy over 36, right? Okay, so it's xy. So this is the xy over 36 here. Okay, so this is xy over 36, right? So this is from what? From the previous. Now f of 1 to z. So what is 1 to z means? So x is 1, y is 2, and times z, right? So this is 108. Okay, so now if you simplify that, so what you will get here? So the now in here also, this is 108. Then this is 2z. And x and y, x equal to 1, y equal to what? It's 2, right? So here you have 1 times 2, 36. Okay, so what is my final answers here? If you simplify here, so this is 1 over 18, and this is 1 over 54. So you will find that the answers here is z over 3. So this is the conditional distribution. Of course, the domain, don't forget the domain. So this is the conditional distribution of the z, given that x equal to 1, y equal to 2, right? So it's not too bad. Okay, so now let's take a look here. Now the next one here is I'm going to find the conditional distribution of y and z, given that x equal to 3. Okay, let's take a look. How do I do this? First, I always encourage the student try to write it out. So you say some other function w. Okay, given x equal to 3, I'm looking for y and z's, right? So I'm y and z, given that x equal to what? Equal to 3. So now, okay, so let's see here. Because your condition is what? Because your condition is x equal to 3. So what I need to put on the denominator is the marginal distribution of what? Of x, correct? Now, what is in here? I need to put this is f here, x equal to 3. So it's 3yz, correct? Okay. All right, so now let's go back to my previous video also. Let's take a look. Oh, what is the marginal for x here? Oh, x over 6, right? So good, we have that. We still have that saved. So in here, let's say, okay, the marginal is x over 6. And then what is my top here? My top is 108. So it's 3 times y times z. So here I have 108, 3 times y times z. Then x equal to 3, so it's 3 over 6. Okay, now you can write it. This is yz, and for the 18, right? So this is x equal to the 1, 2, 3, y equal to 1, 2, 3, and the z equal to 1, 2, right? So this is the conditional distribution of y and z. See here, because of y and z, that's why given that x equal to 3, so x is not there, it's a conditional distribution for x, y, and z here, right? Clear? Okay, so that's good. You know, we have to get those basic concepts done very good, like conditional, marginal, joint, because in the next chapter, when we talk about the expected value, we're going to go back to the same example, try to use the marginal to find the marginal, you know, the expected value, those things, right? So those are very, very fundamental. We have to know it very well, right? And I don't think it's hard because, you know, for the conditional, is just go back to like our probability definition before. Okay, so now, okay, so now for the conditional density, if this is the continuous, right? So if this is a continuous and then it's the same things here. So if you want to find a given y, then your button is y. If you want to find a given x here, then your condition is gx here. And then the gx is here and the hy, that's the marginal. We did some example from our previous video to show you how to do the marginals, right? So you just integrate that out. Okay, let's take a look here. All right, let's take a look. This is the same example we did before. All right, so let's see how do we do this. All right, so this one's here. Okay, we want to find the conditional distribution of x given y equal to some constant. All right, so first things here, let's write it out. So let's just use some different function, doesn't matter. So this is x given what? Y equal to some value, little y here, right? Okay, so where is you going to put it on the bottom here? Hey, remember, this is the conditions, right? So this is the condition. So I need the marginal what? I need the marginal distribution of the y. And then the top here, I need f of x, y here. This is the example we did a while ago for the previous video. So let's go to find what is the marginal we did so we don't need to redo that. So here, let's see here. Do we get a marginal? Yes, here, right? So it's 1 plus 4y, 1/3. Oh, good job here. Okay, so this is 1 plus 4y. So this is 1 plus 4y and over 3. Then f of xy, this is 2/3 x plus 2y, correct? So if you simplify it a little bit, and this will give you 1 plus 4y, then this is 2 x plus 2y, or you can simplify like this is 1 plus 4y, then this is 2x plus 4y. So then you can, you know, whenever they give the y value, you can substitute and you can get the conditional. Okay, now the problems here, they give you very interesting, right? So they said find the probability x less than 1/2 and y equal to 1/2 here. So that means this little value y is equal to 1/2. I already have my the conditional PDFs, right? Okay, so now I can write this was here. So I say this conditional PDF, the x here. So now my y equal to what? My y equal to 1/2. So this will be the 2x plus 4 times 1/2, right? Then 1 plus 4 times 1/2, correct? Okay, so this is 3, this is 2x plus 2. All right, so I take care of this one. Now I need to find the probability of x is less than 1/2. So now I know this one's here, this is a probability x is less than or equal to 1/2, given that y equal to the 1/2 here. All right, so now this will just be equal to, because 1/2 I already take care, so it's here, right? So I'm basically integrated 2x plus 2, then the dx is less than or equal to 1/2, because the x value is from 0 to 1. So remember, for the continuous is less than, so where am I integrating to? From 0 to 1/2, right? So I hope that everybody can know how to integrate this one here, right? So I will let you to practice your calculus integration. And so the answer here is 5/12 here. Okay. Okay, so that's what is the conditional, the distributions, right? So it's pretty, I think it's very similar. And so that's how do you, get it. So like if you change the y value, you can just change the y value to the conditional PDF here, and then you can get it. Okay, so the next thing here is the independence, right? So how do I define the independence random variables here? So let me try to do a brief review for you also, right? So this one's here, I don't know you remember or not in the probability. So we said, if you don't remember, you need to go to review your probability unit again, because those have the, like I cannot stress, the more those concepts are really the fundamental. And if you start to get, if you start to feel that you're lost here, you need to go back to review it, because then all the remaining chapters, they're all related to those fundamental concepts here. Okay, so if we say A and B are independent events, right? That's what we did in the probability. So we said that if A and B are, they are all the independent events. Remember also we said don't confuse the independent with mutually exclusive. They are totally different. So if the A and the B are independent, then the A intersect B is equal to PA times PB. So here is the science here. So let's say if the x1, x2, xn, they are, if each random variable, they are independent, right? Then your joint PDF will be equal to your times each individual. So it's the same things here, right? So your times each probabilities here. Cool? Okay, so now let's take a look at these ones here. Let's say, given the independent random variable x1, x2, and x3 with the probability density, so each one of them, they are their individual probability density. And here they say, hey, those are independents here, right? Okay, so now because they are independent, so the first things they say, find the joint. Find the joint density. After you find the joint density, then let's try to evaluate these numbers here. Okay, so here we say, hey, the joint density, all right, is pretty easy, right? Because they are independent. So basically, I'm looking for f of x1, x2, x3. Okay, so can you tell me what is x1, x2, x3? Well, you just times it because the x1, x2, x3 are independent. So we just be the e to the negative x1 times 2 to the e to the negative 2x2 times 3 to the negative 3x3. So combined a little bit. So this is 6e to the negative okay, so we say it's negative x1 minus 2x2 minus 3x3. Okay, now I'm going to find the probability. All right, here, here we have a little bit of this ones here. We need to be very careful here because they say, hey, they did not just give you each individual range. They said x1 plus x2 has to be less than 1. X3 has to be greater than 1. So this is their each individual domains, right? So if they just say x1 greater than 3, x2 greater than 5, then the integration will be pretty easy. So in here, we need to be careful because they say x1 plus x2 is less than 1, and x3 has to be greater than 1. So x3, I don't have a problem. So basically, I need to integrate from where to where, from 1 to infinity, right? Because it's greater than 1. But these ones here, we really need to be careful. Okay, so typical here, this is where the student get lost here. So when you do the integrations, right, you graph it. So this is x1, this is x2. If just by itself, x1, x2 will be the whole first quadrant, right? So let's say x1 plus x2 less than or equal to 1. So it's a lines here. So let's say x1 equal to 0, x2 equal to 1, x2 equal to 0, x1 equal to 1, right? So this lines here, this is the x1 plus x2 equal to 1, right? And then they want to find that everything x1, x2 here. So they want to see is less than, right? So they say this one is less than 1. Okay, so how do I get less than 1? So here, this area is the area right? So this is how do you do in your algebra in the inequalities, right? So this pink, the purple area will be the area is less than 1 because if you choose 0, 0, 0, 0, you plug 0 plus 0 is less than 1. So you know this pink area is 1. Okay, so I'm going to integrate here, right? So my probability here, so let's see, this is x1 plus x2 less than equal to 1. This is x3 greater than 1. Okay, so how I'm going to integrate? I'm having, because I have 3 variables, right? So I'm going to have 3 integrations here. Okay, so now I'm going to integrate dx1, dx2, dx3. Okay, so be careful. Right now, x1 and x2, they do have a relation. They have x1 plus x2 less than 1. So I need to integrate in that, in that purple area. So that means when I integrate the x1s here, right? Think about it. The way we do integration, we say, hey, here, I'm doing the x1s here, right? That means I'm integrating this area, x1, where it start. It start from 0, but where it end at this line. So this line is here, the x1 is equal to what? 1 minus x2. So they integrate to 1 minus x2. Cool? Okay, so after you finish this direction, then your x2 will just basically is what? Well, basically is 0, 1 here, right? Because that's why your, like take a look here. So now in here, right? So the x2 is just vary from the 0 to 1 here. Okay, so now let's take a look. What is x3? X3 has nothing to do with x1, x2, so it's good. So x3 is greater than 1, so we already say it's 1 to infinity. Okay, so for these ones here, and remember that, right? So now for first ones here, you are doing x1s here. So if you're doing x1, that means this is your only variables here, right? So all the others are constants. Then don't forget, after you integrate, you need to plug in 1 minus x2 as the variable. So in here, I'm just going to do one layer, and then you'll be able to do the remainings, right? So this is the 6. So I can move all the others to here because this is the constant, right? Okay, so in here, inside here, this is e to the negative x1. So the integration is negative e to the x1. Then what is your upper bound and the lower bound? So it's 1 minus x2. Okay, now the next one, you do the dx2, dx3. So when you substitute the x2 here, so now you can combine it with x2s here. Okay, so I did this integration, and I strongly recommend you try to review your calculus 2 and then see whether you can match my answer, right? So the final integration, this will be 1 minus 2 e to the negative 1 plus e to the negative 2 and e to the negative 3. So we'll be very close to the value 0.02. Okay, and like I mentioned, this is a statistic class. It's not the calculus class. So I'm not going to spend too much time to show you how to do the integration. So if you still have trouble, if you struggle with integration, you might want to review a little bit about the integration, especially remember some of the integration formulas. Okay, so that's it. All right, so that's it for this chapter. We finally finished this chapter, the random variable and the probability distribution, the PDF, CDF chapter. Like I said, it's a super, super, super important chapter. Cannot put more emphasis on that. So our next chapter, we're going to talk about the expected value, and that is another very, very fundamental chapter. And so we talk about a lot of fundamental concepts here. Okay, that's it. So I think basically I can I feel like for this chapter, the concept is very similar, very simple. Sometimes students struggle is because of the calculus part, right? So make sure, you review your calculus and you know how to do it, okay? All right, that's it. It's so nice to talk to you. And finally, we finish this chapter, and I cannot wait to go to the next fun chapter. We talk about expected value. All right, so that's it. And nice to talk to you. And if you have any question, feel free to send me an email. And my email address, is listed at the beginning introduction slide. It's shikomathlab@gmail.com. All right. So if you have any questions or you have any requests, please send me an email, and I will answer your email there. Okay, that's it. Have a good day, and I hope you enjoyed these videos here. Okay, so nice to talk to you, and so looking forward to talk to you about the next chapters here. Okay, bye.